Alright, let's take a look for a second on how exactly we can calculate the amount of energy that an object has. So here's our situation. Imagine we have this half pipe and you have a skater in the half pipe going back and forth. So this person will start from over here, they'll skate up to one side and down the other and go back and forth. And we'll say that the mass of the skater is 60 kilograms. And then he starts at a height of 6 meters. So he's 6 meters above the ground right there. So the first thing we'll look at is actually how to calculate gravitational potential energy. And the equation for this, gravitational potential energy, is equal to mass times the acceleration due to gravity times height. So in this case, if we want to find the gravitational potential energy of the skater at this point, what we can do is we can say that the gravitational potential energy is going to be equal to his mass, 60 kilograms, times the acceleration due to gravity, which at the surface of the Earth is always 9.8 meters per second squared. We can also use 10 if you'd like. And his height above the ground is 6 meters. And so now all we have to do to figure out his gravitational potential energy is multiply those through. So we take 60 times 9.8 times 6, and we get that he has 3,528. Well, my oh my, we need units for energy, and that unit is called the joule, and it's abbreviated with a capital J. If you're wondering how that's spelled, it's J-O-U-L-E, which is not how you would expect, but this is after a person's last name. So the unit is the joule, and the abbreviation for it is a capital J. So at this point right here, we have calculated that person's gravitational potential energy. But let's say, just for argument, that at this point right there, this person is moving with some speed. And we'll say it's a pretty slow speed. They're moving at 1 meter per second. We can also calculate kinetic energy of this. And for kinetic energy, the equation for that is that it's 1/2, or 0.5, times mass times the speed squared. So in this case, when we go to solve this, we say that the kinetic energy is equal to 0.5 times 60 times the speed squared, which really means that we're going to multiply by the speed twice. So 1 squared is easy enough in this case. 1 squared is 1, so this is really just 0.5 times 60. So the amount of kinetic energy in this case will just be 30 joules. Notice that the unit of kinetic energy is the joule as well. Now what we can do is we can find the total energy of the skater at this point. To find that total energy, all we have to do is add the amount of gravitational potential energy to the kinetic energy, and what we find, I'm just going to write this here, that the total energy is equal to the kinetic energy plus the gravitational potential energy, and I'll rewrite that in equation form for you. So in this case it would be 30 plus 3,528. So the total energy is 3,558 joules. So two pretty simple equations. The only thing that you can really get tripped up on is if you forget what g is. Remember, the acceleration due to gravity is always 9.8 meters per second squared at the surface of the Earth. Or if you forget to square the velocity in the kinetic energy equation. That happens quite often as well. Now let's look at a slightly more interesting situation with both of these. The skater is going to skate back and forth through this. What if we want to know what the kinetic energy is at this point, at the very bottom, where it's just 2 meters off the ground? We can actually figure that out from just what we have now. And the way this works is by using the law of conservation of energy. The law of conservation of energy tells us that everywhere along this path, unless he is losing or gaining energy to something, and we're going to assume that this is a frictionless track so that he's not losing or gaining energy, everywhere on this track, the total amount of energy should be equal, or should be the same. Now we've already figured out what the total amount of energy is. It's 3,558 joules. So at this point right here, we can say that the total energy will be exactly the same as it was before, 3,558 joules. So what I'm going to do is I'm going to do work over here, this new problem of finding the kinetic energy there. So I know that the total amount of energy is equal to the kinetic energy plus the gravitational potential energy. I want to know what the kinetic energy is. I know the total. If I just knew how much gravitational potential energy there was, I could figure this out. Well, I have his mass, I have his height above the ground at that point, I can figure this out. So I can say that his gravitational potential energy is equal to mass times acceleration due to gravity times height. Plug in what numbers I know. I know that the mass is 60. Acceleration due to gravity is still 9.8. And the height in this case is 2. So I can figure out that his gravitational potential energy is 60 times 9.8 times 2, 1,176 joules. And now, plugging all this other stuff back into my equation, the total amount of energy was 3,558. I don't know what the kinetic energy was. I do know, however, that the gravitational potential energy, because I just figured it out, was 1,176. So what I can do is subtract 1,176 from both sides, and that will allow me to find what the kinetic energy is. So 3,558 minus 1,176. The skater at that point has 2,382 joules of kinetic energy. And so I was able to solve that problem using the law of conservation of energy and the fact that I now know how to calculate both of these.